Every time your phone unlocks with your face, every time a chatbot answers a question, every time your email filters out spam, a machine has learned to do something nobody explicitly programmed. But here's the strange part. At the heart of almost all of it sits one single idea. An idea so simple, you can explain it with a ball rolling down a hill. This is gradient descent, the algorithm that teaches machines to learn. And in the next few minutes, you'll understand it for real. Not the buzzwords, the actual mechanism. First, let's strip away the mystery. An AI model, any model, is just a function. Numbers go in, numbers come out. A photo is numbers. A sentence is numbers. The prediction that comes out the other side, also numbers. Inside that function are parameters. Think of them as knobs. Each knob changes how the function behaves. Turn one, and the output shifts a little. A tiny model might have 10 knobs. Modern language models have billions. Nobody could ever set them by hand. So we let the machine find the settings itself. That is what learning actually means. To find good settings, the machine first needs to know how wrong it is. So we give it examples where we already know the right answer and let it guess. Then we measure the gap between its guess and the truth. Squash all those gaps into one single number, and you get what's called the loss. High loss, the model is badly wrong. Low loss, it's doing well. And suddenly, learning has become something much simpler. We don't need the machine to understand anything. We just need it to make one number go down. Here's where it gets beautiful. Imagine a model with just 2 knobs. Every possible combination of those knobs is a point on a map. And at every point, the loss has some value, some height. Plot that height everywhere, and the loss becomes a landscape. Hills where the model is wrong, valleys where it's right. Training a model means one thing: finding the lowest valley in this landscape. With billions of knobs, the landscape has billions of dimensions, impossible to picture. But the rules stay the same. So this is the picture worth keeping in your head. One problem: the machine can't see this landscape. Computing the loss everywhere would take longer than the age of the universe. It's like standing on a mountainside in thick fog. You can't see the valley. You can only feel the ground under your own 2 feet. But that's enough, because calculus gives us a tool, the gradient, which tells us, right where we stand, which direction is steepest uphill. Flip it around, and we know exactly which way is steepest downhill. So the strategy is almost embarrassingly simple. Feel the slope. Take a small step downhill. Then do it again and again. Step by step, the loss falls, the guesses improve, the machine learns. That is gradient descent. That's the whole idea. There's one setting left, and it belongs to us, not the model. How big should each step be? It's called the learning rate, and it makes or breaks everything. Too big, and you leap right across the valley, bouncing from wall to wall, sometimes even climbing out of it. The loss explodes instead of shrinking. Too small, and you creep downhill so slowly that training would take centuries. The art is in between, steps big enough to move fast, small enough to settle into the valley. Now scale the whole picture up. Show the model a batch of examples. Measure the loss. Compute the gradient. Nudge every one of those billions of knobs a tiny step downhill. That single cycle is the heartbeat of all deep learning. And because checking every example at every step would be far too slow, the machine estimates the slope from a small random batch each time, so its path wobbles its way downhill. That wobble even has a name: stochastic gradient descent. Repeat the loop millions of times on warehouse-sized computers, and something remarkable happens. A function that started as random noise begins recognizing faces, translating languages, writing code. Nobody told it how. It just kept stepping downhill. So the next time someone tells you AI is magic, you'll know better. It's a function with knobs, a number that measures wrongness, and a simple rule repeated relentlessly. Feel the slope, step downhill. If this made something click, subscribe. There are a lot more layers to uncover. This is Hidden Layers. And that was Gradient Descent.